To be honest, I didn't understand a word, but great. So microphone is working? Okay, let's see how this runs. So welcome everybody. I'm very thankful to be invited here to first time being in Minsk, as you may be expected for a German person. So I'm going to speak about Liberator. Liberator is a closure library to implement REST resources, so REST in the HTTP sense of REST. I know this is a very, well, complicated term nowadays. But anyways, I will show how this is done in Liberator. And warning ahead, Liberator is opinionated, so it's not about HTTP, RPC style APIs. But anyways, let's start. So Liberator is implemented in Clojure. First, a small question, simply hands up. Who knows Clojure? Oh, that's great. Who uses Clojure? That's also great. Are there like Scala people? No? Okay, I expected there would be more or something. So just a small introduction. Clojure is a Lisp, a modern Lisp, running on the Java virtual machine. Oh, I'm standing in the way. It has a REPL. There's also Clojure script which targets JavaScript, which is nice, but I'm not talking about that today. Next year, if I did the math correctly, Clojure turns 10, so it's 10 years of awesomeness. It really is. One of the most important things with Clojure are data structures. Those are normally immutable and persistent, so they're structured sharing. They're based on a persistent vector, also known as bitmap vector tries. The typical access time is something around log 32, and which is practically fast enough because you need at most like 5 hops and then you're at the location you want to change or look up. There are vectors, hash maps, sets, and all kind of stuff you would expect from modern language. One important part of Clojure is the use of keywords. So keywords evaluate to themselves. So this is a keyword. You use them as ad hoc identifier, where in like other language you would maybe use a string constant, or in Scala we would use something like an enum type. In Clojure, you just use a keyword where you need it. Keywords are also functions. You can use them to look stuff up from maps. This is important, we will go into that later. So just short introduction into Clojure's syntax 101. Yeah, there are a lot of parents, of course, with any Lisp. It is. And that's how Clojure's syntax look like. You have a function application here. The only thing different from, I don't know, any other algo syntax-based languages, that normally you have the open parenthesis here, and now it's here. That's the only difference. So you can nest function calls. Well, that's how it works. That's how Clojure function or Clojure code typically looks like. Math is always weird because of prefix notation. The FN syntax here is to introduce anonymous functions like a lambda. You can close over the context, like in every sensible functional programming language. You have, for higher order applications, the keep functions selects all elements of a collection which are true according to a predicate, which is odd in this case. So this could return a vector. Actually, this is wrong. Will not return a vector, but it will return 1 and 3. So Clojure maps are important when we model data or information in Clojure. You use keywords as the keys, and in this case, strings as the values. Clojure supports map destructuring, so you can take this p-value from above, which is a map here, and bind the local variables or local variables f and l to the values at first name and last name. This is how this works in Clojure, which is a nice feature. And when you apply a string function which concatenates all the values, you get this back. So L is bound to last name, which is Meier, and all that. More about keywords, just important because, once again, the map, you can use the keyword as a function and retrieve the value. You can use maps as a function, which like the other way around, and this both gets basically calling a get function on the map, but nobody uses that. But I think I don't need to repeat all that for those people who know a little bit of Clojure, and the other ones I guess will be able to follow along. So in Clojure there's Ring. Ring is a specification how to integrate web handlers, HTTP handlers in Clojure, or how to connect your Clojure code to a web server like Jetty or another Java web server. There's something similar in the Python community. I don't remember the name. So it's basically a specification how to do HTTP service implementations, and all the request handlers are Clojure functions. So you get called with a request, with a data structure describing the HTTP request, and you return a response. It's a little bit like CGI. So a little bit on history of a Liberator. So the best way to predict the future is to invent it. So I was new to Clojure. I was looking for a problem to solve because I liked the language. I did web applications since 1996. I knew Erlang's web machine, which shares the same basic ideas with Liberator. This was November 2009, according to the Git log, which is quite a while ago. I did Liberator, and there was the first Euro Clojure in 2012, and suddenly a guy showed up and did a talk on Liberator, which is Malcolm Sparks here, sitting at the corner, working on his slides, I guess. And suddenly things got speed. HTTP is actually huge if you want to support it semantically correct. It's also complex. You have requests and responses, headers and body, methods, status codes, content negotiation, conditional requests, and even more. And this is only like the semantical level, the application layer on top, and not the like the wire level. HTTP 2 nowadays has all kinds of weird like transport level wire network protocol, which we as application developers normally can ignore, which is a good thing. HTTP has a lot of methods, 8 in total. According to RFC 7231, these are get, put, post, delete, head, options, trace, and connect. And I bet if you do web applications, you maybe have used get, put, post, delete, maybe head, maybe options, but trace and connect you never do, I guess. So connect is actually for something like upgrading on HTTPS, or used to be used for upgrading HTTPS connections to a secure transport. There are more RFCs for patch, for example, and WebDAV, totaling at what's now 8 plus 1 plus 7 is 16 methods. Then there are header fields, 47 the last time I counted. Maybe now it's more, from accept to www-authenticate. There are status codes, 5 classes of status codes: informational, successful, redirection, client error, and server error, and those are meaningful. This is important, actually. Sorry, and I'm a teapot, right. I will come back to that later. So if you're requesting a web service, an HTTP service, and get back something 400, you know it's your fault. You can do something about that, and maybe it works. If you get back a 500 error, there's nothing you can do, maybe except waiting that someone on PagerDuty got the notification and fixes your system by, of course, restarting it, because that fixes most of the problems. HTTP status codes, 41 in total, according to this RFC. Well, WebDAV adds another one, which is quite useful. And there's HTTP, which is the Hypertext Coffee Pot Control Protocol, which adds 480 and I'm a teapot, which is quite important. So 41 status codes means this is like below 2 to the powers of 6. So this is the maximum number of needed decisions. If you want to support all of those 41 status codes, you need to make at least 40 binary decisions. If you imagine, like, somehow my code needs to decide which of those 41 status codes to use, and when you assume you do like a simple if-else, then you need at least 40 branching points. No way around this. Well, most of those status codes you will never need, but you need to consider them. Back to Ring. So this is how Ring works, basically, or an HTTP handler based on Ring works. You have a map describing the request, the HTTP request. Typically, you have a request method, so get, put, post, and all that. You have a map of headers, and you have, at least for some of the requests, the body. And in the end, you need to come up with a response. The response in HTTP consists of a status code, some headers, and a body. Well, the body is optional, but most of the responses will have one. So how do we tackle this? Well, this is what we want to do. We have a handler function. This is what you want to write, which is called with the request, and it should return response. Quite easy. How do we start? Well, somehow we need to dispatch on something. So my handler will look roughly like that. I will get past the request, and then there's some conditional happening, and in the end you will end up with one of those status codes somehow. There's some code which produces 503, which is, who knows this? I don't remember. Method not supported? No. Internal server is not, server is not available, I guess, or something around that. And 501 is another server error. 403 is forbidden. I don't even know them. And finally, the happy path, we will respond with 200 somehow, which is OK. So there's a lot of question marks. How to do this? Let's do the simple way. Keep it simple. Most simple case, we simply return a static response map with a 200 happy path status code. Content type is text HTML, and the content is a talk. This is a hypothetical resource handler to look up all the talks from a conference. Well, now we need to take into account that this handler could be called with something else than get, but we only support the get method. So we need a branching point here. We compare, we do some destructuring, extracting the get request method from the request map. And we compare. If the method is get, then we're in the happy part. We respond with 200, and we use a find session hypothetical database method to look up the talk and return it. PR string is something, a closure function, which returns a closure code representation of the data structure. So it's a very simple way to convert a closure data structure to something, to a string in a decent and nice format. And if it's not get, we return 4 or 5, method not allowed. Quite an easy, right? Well, the font size is getting smaller now because we need to take into account that we didn't find a session with the given ID. So we have another branching point. So if let is a combination of if and let enclosure. So we try to find a session, bind it to the local variable e. And when it works, so actually the code is bad. We should have simply printed e here. If this works, we print it again. And if we didn't find a session, return 44 not found. And can you still read this? I don't think so. Yeah, so I will explain to you what this is supposed to do. I guess this added content negotiation. So basic on the accept header, we can either return application closure, which is a closure representation of the data, or text HTML, which adds some formatting and all that. And if the client requests a representation, a media type, which is not supported, returns 4 or 5, I guess it is, request media type not acceptable, and all that. So this is quite tedious to do. And well, what's going on? Here we support last modified header, so conditional requests and all that. And you see it's a lot of code for like the business functionality basically is, where is it here? Find session. This is all we want to do. We want to look up the session and then either return it as a closure data structure or return it as HTML. So this is quite a lot of work, and we're still not at the end. So what do we do here? We basically have a lot of conditionals here. We have a branching point, a branching point, a branching point, a branching point, branching point, and return one status code, another status code, another. And this is only for 7 status codes, and it's quite a lot of code already, which is all like plumbing code. And you always want to get rid of this kind of boilerplate. So we want to extract the decision flow. What you see in the background is a graph of Liberator's internal decision flow, and one of the most messy parts. And this is because HTTP is such a big protocol and supports so many ways how you can end up at a particular status code. And that's how things are. And as a developer, you don't want to fight this every day. So I want to show you a small demo on how Liberator code looks like. And live coding is always fun because it's a lot to learn from the mistakes of the presenter. And it starts with switching displays without getting lost where the mouse pointer is. Where are we here? Oh, okay. Maybe we should lower the font size. You can still read this, right? Yeah. Okay, so this is the pre-prelude. We need to declare our namespace, import all kinds of stuff. If you know Clojure, you know this. If you don't know Clojure, this is like Java imports. This is weird. Well, it's this import. This is wrong, actually. I guess I pressed the wrong button. And as this is Emacs, it does magic things. Yeah. Fixing. So, there we go. Evil mode to the win. Okay, this works. Yeah, this is the real prelude. So we declare a talk variable which will hold our handler function. We define an app which uses something called wrap parents, which is a handy way to, when you think about the ring specification again, you want to have a simple access to the query parameters. You don't want to do the query parameter parsing yourself. So wrap parents wraps your function with some pre-processing, so you have the query parameters at hand. And we define a Jetty web server on port 4000, which calls, you can see this, into our app function. So this is all like prelude. So let's begin. We declare a ring handler and bind it to a variable talk. So we can use the resource function, which creates a Liberator resource ring handler. This is quite like boring, I guess. So what happens if I open a terminal? I should. What happens when we, there it is. Wow, a lot of stuff. Well, so it tells me no acceptable resources available, which is HTTP 405, I guess. 4.6, I'm sorry. There we go. That's pretty obvious because we didn't declare a media type, which this resource exposes. So let's define the available media type to be text HTML. And once again, okay, we get a default response, which is still quite boring, which is okay. It's not even valid HTML, so we better do something about that. First of all, we have a shorthand syntax here. Def is a Clojure way to define a variable, to bind something to a name. Resource is a way to, is the function which creates the actual ring handler, but there's a convenience macro def resource, which just saves you a little bit of screen estate. Still works, getting back. Okay, now there's a handle declaration. Handle OK is the handler which is called for the HTTP 200 result. And let's just return, here comes the talk as the response. And there it is. So I will change back to non-verbose mode. It's early in the morning. Typing is hard. Okay, so we managed to expose some data on HTTP. It's not so impressive yet, but it's at least not much code. Given that we now have content negotiation, when I send that I only accept text plain as a client, I should get back 4.6, or no, 5. I never can remember. What's the syntax for including headers? Yeah. 4.6. So the server now tells me, I'm sorry, I don't have text plain. So this is quite nice. Imagine you wanted to have use the service with an, I don't know, Android app, and you want to have, what is this, application JSON, right? Application JSON. It should return no acceptable resource. I'm sorry, I don't speak JSON. So we never implemented this. We just declared we support text HTML. So it's quite convenient. In the handler function, you not only can return, like in this example, a fixed value, you can also return or declare a function. So you can react on different situations and actually do some real processing, because returning constant value doesn't give you so much power. So for some real data, so I've created a function find talk, which is a fake database. And in the handler k function, we will like get in, which is a deep lookup. In the context, we look up the request map, then the params map, and then the ID value, which is mapping from the query string ID, or pointing into the query string ID. Pass this to find talk and return the found data. So let's see what happens. ID is, what's the example? Better be sure that this exists. Well, finding shell syntax in the morning. Okay, still not acceptable. Oh yes, we still requested application JSON, so get rid of that. So we got back some data, text HTML, and this is a talk actually from, I don't even know, a former closure conference, I guess, the fake data. But you see, we get back text HTML, and there was some automatic formatting. This is one of the neat points of Liberator. You see, we don't do any HTML generation here. The find talk function returns, we can just try it out here. Find talk, what was the parameter, 10, I guess. I think we need to do it as a string. Find talk, yeah, this is the value that's actually returned by find talk. But this is not the value you see on as the HTTP response. You see something which is like a little bit nice HTML as a convenience. We can look at this in the browser. Local host 4000 ID was, what was it, 10? 10. Okay. You see? Nice and easy. This is quite convenient when you do some like explorative programming, want to expose some data on an API, toy around, and just have do some quick progress. What happens if we request an ID which doesn't exist? Let's say this. Wow, this is not so good. It returns 200 okay, and I don't think it's okay when you request a missing talk. Maybe we can do something about it. And for this, there's a callback function declaration exists, which is called before the handler and just determines whether to return 200 or 44 not found. And if we try the same again, what happens? We get 44 not found, and the basic default answer resource not found, which is fine. And when we go back and request number 10, we got back our response. But this is a little bit annoying. We repeat ourselves here, right? And you know, repeating in code is always bad. I learned in Programming 101. It's getting a little bit more complicated here because we need closure syntax. I better get back to the big word. So the exist functions get past the context. The context always carries the current state of the processing throughout your HTTP resource request. And we try, once again, to find the talk using the parameter ID from the context and all that, and we bind it to the local variable talk. And now, if this is true, we return a vector containing two elements, which is the closure way to encode like a tuple of two elements. The first value is used as the like binary result of the decision function. So if we return true, this means the resource exists. If we return false, it means no, this resource doesn't exist. And the second value is used to update the context. In this case, we do it the explicit way in assoc, which is a map put, basically, to the keyword talk, the value of talk we just looked up. So we bind talk to this keyword in the context, and if we didn't find the talk, we just return the context. So later on processing, Liberator determines that we should respond with 200 because exists return true. And it calls handler k, passing the context. And the only thing we need to do is we look up again the value from the context at the key talk, which was bound here. And here we can look it up again. So we don't need to repeat ourselves. And if this works correctly, we can see that, yeah, it's still returning the talk as expected. And if we request something not existent, it's still 44. Okay, we can simplify this now. So nil is an alternative value enclosure for returning false. And if we return not a vector but a Boolean value, it's just the context isn't touched and processing continues according to the Boolean outcome. And what's the difference here? Yeah, we can, with closure, simply omit the else case, and this evaluates to nil. So the code gets a little bit more compact, and it seems still to work. And there's the convenience in Liberator. You don't need to update the context yourself. When you return a map, the map values are simply merged with the existing values in the context. So it's even more expressive this way, and it's less code, and less code normally means it's easier to understand, unless you're a Perl or, I don't know, Haskell programmer, where less code means it takes longer to understand. And if you remember earlier, I told you that closure keywords are functions which can be used to look up values from a map. So we can just use the talk keyword here as a function, and this will look up the value from the context at talk. So this is handy, even less code, and don't mind the double colons here, the double colons, which is a way in closure, if you don't know it, to declare a keyword which is like bound to the local namespace. Normally the single colon keywords like these are in a like global universal namespace, and this double colon thing is only like bound to the local, what is the Liberator presentation workspace and working it. This is kind of a best practice thing, but don't worry too much about it. So now we can use destructuring. You remember, when you go back to the last slide again, this is like quite some code to get into the context and request param, look up the ID. You can use closure destructuring syntax, which is nice, so we can destructure. This whole thing here is the request map. How can I highlight this? This is the request map. Then we go basically bind into the request key, another map into the parents key, and then finally into the ID key and bind the ID. So it's even less code, nice and easy, just making sure it still works, right? And we maybe want to support more media types. So closure has as a convenience out of the box, how would you call it? Serializers in normal web frameworks. In closure it's a representation. And it supports like text HTML, JSON, Eden, which is the closure data format. So like maybe it's comparable to how JSON relates with JavaScript. This is how Eden relates with closure. And now we can try different media types. You remember we could not make an application JSON request. Now we can, and we get back properly formatted JSON, which is nice. When you do front-end work, you want this. Or you can have Eden, which looks a little bit like JSON, and this is basically a closure syntax this is closure for data. So it's the same syntax as closure, but just for data and not code. What's next? We can add more handlers. You remember when we asked for an media type which is not supported, for example, I don't know, image, PNG? Well, the answer is no acceptable resource available. But it's best practice in hypermedia to guide the clients and to tell the clients, even in an error case, what could you do? It's not like a bouncer at a nightclub who just tells you you're not allowed to enter. Maybe he should tell you it's because of your shoes or your hair color or your age or whatever. So let's fix that. There's another handler not acceptable. And what we do here is we return a string which tells us or tells the user the available options. So adding a new handler is quite easy, and when we retry, we get back that, well, the available media types are text HTML, application JSON, and application Eden. So something which would, when you do this manually, need quite some code. Especially the accept header parsing content negotiation is not easy. It's also quite complex, actually. This takes time to implement, and you get this very quickly with closure. So content negotiation is not much of a deal nowadays anymore because everybody uses, I guess, JSON or some custom format, and you have typically I don't know, a smartphone app talking to a backend service or a front-end web app talking to a backend service, and it's often that you're in the same company, and so you once settle on, we use, I don't know, protobuf, or we use JSON or something. But another thing which is important is conditional requests, which enable the web actually to scale. So we want to return the last modified date. I have a helper function which just returns a timestamp, which is the begin of the last minute. So this timestamp changes it's a fake timestamp which changes every minute. And now we declare simply one declaration here. We declare simply one helper function which is last modified, which calls into this fake function. It could also use a timestamp from a database or whatever is useful to describe your resource changes. And when I look this up now, you see we get back the same data, but a new header, last modified. So this was modified today, a couple of seconds ago. And you see, if I retry, it's always the same timestamp. And when we wait until the next minute starts, it should change. What's the time? Do it now. Oh, 8 seconds ago. Can be so long time. 8 seconds. Where is it? Do it. Oh, it's broken. There we go. You see, it changed. So, when we do now a different call, and I have, I guess, 60 seconds to fix this. Ooh. And we provide the correct date format. HTTP date formats are a mess, I tell you. No, it's Saturday, right? Saturday, December 10. What? No, it says in 10. I need to use the date from above. Quick, time is running, live coding is fun. Okay, great success. We get back not modified. So this is how caching in HTTP works. And this saves you a lot of resources. It makes a difference because this is directly affecting your, directly affecting your bill on the hosting. So, yeah, the same is possible for etag, which is like kind of a checksum value for a database, not time-based, or yeah. So one thing I want to show you, and this is nice in Liberator, is we have a way to trace the execution because you can easily get lost in all those decision functions, and when you do run into an error, you want to see what happens. So when I enable this tracing function, you see an additional stack of headers returned from resources, which are the trace, what happens. So service available, yes, known method is get, URI too long is false, method allowed is get, and all that. Media type available, you see there's a representation going on and all that. So this is quite nice and easy to debug. So where's my oh, I hate it. Where's my where's the other one? So I guess we're close regarding time, right? How long have I to go? Okay. So this was the result of the demo. I would skip some slides, I guess, because I'm pretty short on time. So this was the result of the demo, and this was how we did this manually. So if you compare that, this is quite more expressive because it's less code and focusing on the important stuff. So what did we do? We provide the application logic in those handler functions or decision functions. Sorry. And this is just what we need to do. So I just wanted to recap on the execution model. We had been passing along the context, which is the state of the execution. So the context is passed to all those decision and handler functions. And what you do is it's merged. The result of the decisions functions is merged intelligently. As I talked about it, it's considered a Boolean value. Additional optional value is merged with the context and used to update the context. You can return a simple Boolean value, a map which is merged, or a vector if you want to return false and still update the context. The context is built incrementally. It starts with the request. Then during processing, you maybe look up some entities like we did in our example, which is bound to some local keywords as talk, for example. You end up with a representation declaration after content negotiation, media type, language, character set, whatever. And yeah, that's used to finally generate response automatically by Liberator. There are ways to customize the response, of course, but I don't want to go into details here. Just a small introduction how this is implemented, actually. Clojure loves data. Those resource definitions are maps of functions, which is easy because you can manipulate maps, you can reuse the maps, you can declare a base map for all your services, and then use individual maps where you have those service or handler specific functions updated. Yeah, this is the map of functions, basically. This is a map. See the curly braces? This is great. This is how it's implemented internally. You remember this big decision graph? This is the Clojure code. It says, it starts here, initialize context, the first function, and in any case, proceed with service available. Service available, if yes, go to known method. If not, go to handle service not available. Known method, if yes, go proceed with URI too long. If it's not a known method, call handle unknown method. This is how internally Liberator is implemented, which is quite handy and shows the power of Clojure macros. Liberator is opinionated. There's a fixed decision graph. There are always support tickets like, how do I do authorization before check for assistance or the other way around? There are tricks how you can do that, but basically one of the fundamental principles of Liberator is there's a fixed way in which order all those decisions happen. And in the end, on runtime, it's simply functions calling functions. So if the exist function is true, it calls the next decision function or that. There's a decide function which does the dispatch, which looks like this, a little bit scary. Let's clean it up. So we look up in resource the test function, the then function, the else function, all that. Finally, we do the test. We check if this is a decision, is a vector and all that. We do a context update. And if that's, we return, where do we proceed here? Yeah. Either we call or we return the then function, which is like, where is it? This here, the left hand, or the else function. Wow, this is how the call stack looks then. It's a little scary because it's Java virtual machine and Clojure, but you can see quite handy. We start initialize context, then comes decide, calls handle exception, which runs the handler, calls like generate last modified and all that. Initially triggered by a divide by 0, done on purpose. But this is helpful also in debugging, that you have functions calling functions. When you think about the resource declarations, this is the essential complexity of your resource handler. You need, using whatever technology you want to do, you need to declare a way to check whether a database entity exists or not. This is the core, the essential complexity of your application. But with Liberator, it's often enough to do that. You need a way to look up data from a database. You specify the media types you want to support. You specify a way how to generate an e-tag. And that's it. As I said, Liberator is opinionated. This is a way how to do it. It's maybe not the best way for every application, as support tickets show, but it's quite easy. And you don't want to write the plumbing code, this all if-else code, and parse HTTP headers. And not writing code feels so good. So, small outlook, Liberator approaches feature completeness. There are some rough edges, but for a long time I have not much work maintaining it. I'm looking to alternative execution models, like asynchronous execution, which is doable. Maybe doing something which is more resource-centric and less HTTP-centric. We're still talking about like exist header, modification headers and all that. But there's a nice follow-up, which is Yada, which Malcolm will be doing a talk, which is kind of a like evolutionary progress of Liberator, but not useful for all applications. So there's room still for Liberator. So I thought I would have time for questions. Maybe 1 or 2 questions are possible.
So